So, okay, this is a unit 1 estimation theory. The topic is estimation theory is a table format is there that contain for two type. One is a characteristic estimation and the next one is a method of estimation. Okay, so two type is there. One is characteristics of estimator and the second one is method of estimator. Okay, this is the first one and this one is called a second one. So what is a characteristic of the estimator? So total 4, but the last one is not important one. So first 3 is very important one. So what are that characteristics? Contingencies, unbiased and efficiency. This three type is characteristics of the estimator. And second part is method of estimator. Method of the estimator is contained three part. One is a maximum likelihood, and the second one is a method of performance, and the third one is called a method of least square. This method of least square is contained three type. One is line concept and parabolic concept and exponential concept. This is the three type. This is overall content for the your unit 1 estimation theory. This topic is completed, meaning this unit is also over. So we move to the basic concept of definition. Is what is a contingency. Before that, what is a basic formula? Because this formula using this in this unit, basic probability formula. Okay, probability distribution formula. Basic probability distribution formula. At least you want to study normal distribution and Poisson distribution. Also exponential distribution is also there, a uniform distribution is also there, but very important part you want to study that Poisson distribution and also normal distribution. This is a formula part. What is a formula of Poisson distribution? E power minus lambda into lambda power x divided by x factorial. This is a formula. And what is a normal distribution formula? 1 by sigma root of 2 pi into e power minus 1 by 2 into x minus mu divided by sigma the whole square. This is a formula for normal distribution. Here we know that what mean by mean and variance. Already I discussed mean and variance. This lambda is called a mean and also variance is also lambda. In this place, what is a mean and standard deviation meaning? Mu is called a mean and sigma squared is called a standard. That means variance. This is a basic idea. This you will now means this we want to apply the this corresponding next concept. Okay, I moved to the basic definition. What is meant by contingency, unbiased, and efficiency? This is a very important part in 2 mark question. Okay, based on this definition, may be using in the 2 mark question. So, what is a contingency estimator meaning? Is not that E of t. E of t already you know expected value. E of t you already know expected value. That expected value is mean that mean. Expected value means that mean. Okay. E of t. This t is called a estimator. Okay. This t is called a some estimator. Maybe normal distribution estimator or Poisson distribution. Any one this estimator is there. Okay. That E of t, E is not that expected value and t is not that estimator. Therefore, E of t is tends to some finite value as n tends to infinity. Second condition, variance. This is called a variance. VAR meaning variance. Okay. So variance of estimator it tends to 0 means as n tends to 0. As n tends to 0. This is a basic idea of the contingency estimator. Similarly, if you want to define the unbiased estimator, suppose the estimator is unbiased, then the following conditions are satisfied, and also these are the basic notation and basic formula. Okay, this capital S squared, this capital F squared is formula already you know in the unit of testing up hypothesis, summation x minus x bar the whole square divided by n minus 1. Small s squared is also known summation x minus x bar whole square divided by n. And x bar is called a sample mean and mu is called a population mean. This is a basic idea already done in the multiple variance. So that means modulo pi or and testing of hypothesis modulo 2. This unit already done. This is a basic notation. Okay. Then the given estimator is unbiased. The given estimator is unbiased. Then at least this condition are satisfied. At least this condition are satisfied. So what is the condition? The expected value of population means equal to population mean. Otherwise, the expected value of for the corresponding estimator, okay, corresponding estimator E of t, corresponding estimator is equal to mu. This is the first condition. And the second condition, this value, the expected value of population variance. This notation is called a population variance. The population variance equal to sigma squared. Sigma squared is also the another population variance. And next one is called a E of small s squared. So E of small x squared, this value is expected value of this value is not equal to population variance, sigma squared. Okay, this is not equal to population variance. These three conditions are either satisfied, then the given estimator is called a unbiased estimator. The given estimator is called a unbiased estimator. So what is the contingency estimator? The expected value estimator is finite as n tends to infinity, and the variance of estimator is tends to 0 as n tends to 0. Okay, this definition is called a contingency estimator, and next definition is called a unbiased estimator. Suppose this condition is not satisfied. This condition is not satisfied. That is called a biased estimator. Okay, biased. Hello.
ചിപ്സ് എടുക്കണ്ട
Please mute
ആ
your
കുപ്പിയത്തെ
Sagana,
ബാക്കിയൊക്കെ
Sagana,
ഇരുന്നല്ലേ
Sagana. Please mute yourself, ma. Any question?
I'll call her, sir.
Yeah, yeah.
ഞാൻ പറഞ്ഞു എന്റെ അടുത്ത് അവിടെ വന്നിരുന്നോ ഞാൻ എഴുതാല്ലേ ജയിക്കാം
Sagana, please mute yourself, ma. Okay, thank you. So, okay, then this is a basic idea. Suppose this three condition is not satisfied, then that estimator is called a biased estimator. Okay, unbiased estimator meaning is satisfies this condition. Suppose this condition is not satisfied, then the condition is called a biased estimator. Biased estimator. So next estimator is called a efficiency estimator. That efficiency estimator is another name is good estimator or better estimator. Okay, both are same only. Good or better estimator. Suppose you are taking that T1 is a one estimator in the variance is V1, and T2 is another estimator in the variance is V2. Then the E is called a estimator on T2, then divide that E equal to V1 by V2, that value is less than 1. Okay, very important one, the expected value, that meaning the efficiency estimator value is less than 1, meaning okay, the given estimator is called a efficiency estimator. The E value is, what is the formula? V divided by Vi. Any variance is less than 1, meaning then the given the estimator is called a efficiency estimator. This based on one problem or one theory is very important, 13 mark or 8 mark or 12 mark or 7 mark question. That question is this one. Very important. Okay, based on this two definition, efficiency estimator and unbiased estimator. Based on this two definition, then this question is very important many times in your question paper. Many times in your question paper, maybe 8 mark question or 7.5 mark question or 13 mark question or 16 mark question. Very important one. So what is the question here? Total pi sample values is there, and also normal population. You know the normal distribution formula, already I given that normal distribution formula. Normal distribution formula, mean is mu and the standard deviation is sigma squared. This is a basic notation, already given the formula, the table. What is the normal distribution mean? Mean is mu and variance is sigma squared, and the formula is this one, and the formula is this one. Okay. Then what is the next part? from the unknowns mean is mu. Okay. Consider the following estimator to the estimate. Three estimator is there given T1 and T2, T3. Three estimator values are given. Okay. Then what is the first one? Is given that T3 is a unbiased estimator mu. T3 given that this is given that T3 is a unbiased estimator for the mu. Then what do you mean by unbiased estimator? Satisfies this three condition. Okay, satisfy this three condition. Therefore, only satisfy T3 is unbiased. T3 is given that unbiased. Okay. Now find lambda value. T3 is unbiased, then find lambda value. And also another question. This is a first question. This is a second question. T1 and T3 are unbiased. This is a question. T1 and T2 are unbiased. Then unbiased means you want to show that E of T1 equal to mu and E of T2 is also mu. E of T2 also mu. You want to show that. Second question. Okay. And what is the third question? State giving the reasons the estimator are best amount. This best amount meaning already I am told efficiency good or better estimator. Okay. Therefore, best estimator or better estimator both are same only. You satisfy this condition. What is the condition here? Less than 1. Less than 1 condition. Okay. Then you want to find that the estimated value of variance of V of T1, V of T2, V of T3. Three values you want to find that. Then which one is best? You want to show that. Which one is best? You want to show that. Okay. This three condition apply this theorem. One by one I want to show that. One by one I want to show that. Okay. One by one. So it is a first one. So first one, please go through this very important theorem. So it's a repeated theorem. Therefore, I am explain this one. So what is the first one? Given that T3 is a given that T3 is a unbiased estimator. Given that T3 is a unbiased estimator. Therefore, we know the definition of unbiased estimator. E of T3 equal to mu. This is the first definition. Okay. Unbiased estimator meaning E of T equal to mu. E of T equal to mu. Therefore, here T3 is unbiased. Therefore, E of T3 equal to mu. Now, what is a T3 value? This is a T3 value. Therefore, T3 equal to 2x1 plus x2 plus lambda into x3 divided by 3. Okay, divided by 3. Now, so what is a given entity again? So given entity again is normal population. So normal population meaning you know the mean value. So what is a formula in normal population? Mean equal to mu. Mean equal to mu. Therefore, here you take that E of x1, E of x2, E of x3. All values are E of x1 equal to E of x2 equal to E of x3. So all values are mean only. Therefore, I am taking that corresponding mean equal to mu. Okay, corresponding mean equal to mu. Because here normal distribution, therefore I will taking E of x1 equal to mu only. E of x1 equal to mu. Now we want to find that. It's a first question. Now we want to find that lambda value. Now we want to find that lambda value. Therefore, we want to consider that using T3, you are taking this equation number 1. This is equation number 1. You want to taking E of T3. Okay. Both side taking expected value E of T3. E of T3 equal to, so what is the value is here? E of overall we want to taking expected value 2x1 plus x2 plus lambda x3 divided by 3. Okay, divided by 3. So what is the E of T3 value? E of T3 also mu, because unbiased estimator E of T3 values is mu. So now apply E of T3 value. Now apply E of T3 value from the left side is mu, and what is the right side? Right side one formula is there. E of x1 plus E of x2 plus x3. That means expected value can be written as E of x1 plus E of x2 plus E of x3. This is a formula of the expected value. Separately you can write in the expected value. Therefore, I am writing here, this is a two constant. Suppose A is there meaning you want to taking outside. Suppose here A x1 meaning you want taking A outside. Suppose B is there meaning you want taking B is also outside. C is here meaning you also taking constant term outside. This is a basic rule. Therefore, I am taking outside all term. Then you are getting the result. Then you are getting the result here 2 into E of x1 plus also here 3 is there. Therefore, separately I am put it 3 2 by 3 plus E of x2. Also 3 is there. I putting here 1 by 3 plus lambda is constant. Therefore, lambda by 3 into E of x3. E of x3. Now, formula is normal distribution. Therefore, E of x1, E of x2 and E of x3 all values are mu because here normal population, that means normal distribution formula. Therefore, I am taking corresponding the E of x1 value is mu and this value is also mu and the last values is also mu. Last values is also mu. So, apply all values and simplify is getting the result which implies that mu equal to, so what is the result here, 2 by 3, yeah. Therefore 2 by 3 mu plus next one is 1 by 3 mu plus last one is lambda by 3 mu. Okay, last one is lambda by 3 into mu. Okay, so what is the result of this two? 1 by 3, 2 by 3 is getting the 1. Therefore, this overall result is also equal to mu only. Therefore, mu equal to mu plus lambda by 3 into mu. Lambda by 3 into mu. This mu cancel. Therefore, left side equal to 0 lambda by 3 into mu. Therefore, what is the lambda values here? Just cross multiply. Just you want to cross multiply. This 3 and mu. Moving to this side is also 0. Therefore, lambda equal to 0 only. Lambda equal to 0 only. Now replace by T3. What is the T3 value? This is a T3 value. 2x1 plus x2 plus lambda x3. Here lambda is 0. Therefore, you want put that lambda equal to 0 here. Then is easy, the estimator can be written as T3. The T3 estimator can be written as 2x1 plus x2 divided by 3. Because last value lambda equal to 0, I am omitting that one. Okay, and here lambda equal to 0. This is the first question. Find lambda value. Therefore, first question is over. Up to this one is completed, meaning maybe 3 mark. Okay, first one is over. Second one, T1 and T2 are unbiased. Want to show that. That meaning, what is that meaning? You want to show that E of T1 equal to mu and E of T2 equal to mu. Separately, you want to find that. What are the estimator? T1 and T2 estimator values this two. T1 and T2 estimator values this two. Therefore, I move to the second proof. Second proof. Now, what is the second proof here? First, I am show that T1 is a unbiased estimator. T1 is a unbiased estimator. How to show that? So, it is involved to show that E of T1 equal to mu. This is a basic idea. Okay. So, what is the D1 value? D1 value x1 plus x2 plus x3 plus x4 plus x5 is a given that overall divided by 5. This is a given that. What is a given that? D1 equal to x1 plus x2 plus x2 up to x5 divided by 5. This is a given that. Therefore, I am putting here. Now we are taking both side estimator. Now we want to taking both side estimator. That meaning E of T1. E of t1 equal to E of this overall value. That meaning x1 plus x2 plus x3 plus x4 plus x5 overall divided by 5. Overall divided by 5. That is equal to, already given the formula, 1 by E is a constant, we will taking outside, and the remaining values you know, E of x1 plus E of x2 plus E of x3 plus E of x4 plus E of x5. This is a formula. Now separately you know, all values is mu, all values is mu, because population normal population, therefore all values is getting the result is mu. Now apply and simplify 1 by pi, mu plus mu plus mu plus mu, pi times there, therefore pi mu, therefore pi mu. Now is cancelled, this pi is cancelled, therefore E of t1 equal to mu only. As per definition unbiased estimator, E of t1 is equal to mu, meaning which implies that t1 is called a unbiased estimator. D1 is called a unbiased estimator. Okay, first part is over. What is the second part? Second part you want to show that T2, you want to show that T2 is also unbiased estimator. Want to show that T2 is a unbiased estimator. How to show? Is also you know the part of T2. E of T2 equal to mu. E of T2 equal to mu. So it is a given that T2 value is equal to T2 maybe in the part T2 equal to x1 plus x2 divided by 2 plus x3. X1 plus x2 divided by 2 plus x3. Now we want taking expected value of T2. Expected value of E2 equal to expected value of x1 plus x2 divided by 2 plus x3. Now separately you write, that is equal to, this 1 by 2 is a constant term, thereby writing 1 by 2 is a common in the x1 x2 part, therefore E of x1 plus E of x2 plus last term E of x3, last term is E of x3. So it is the answer here 1 by 2, here E of x1 value mu plus E of x2 value is also mu plus E of x3 value is also mu. Now simplify, so what is the result? That is equal to 1 by 2, mu plus mu is 2 mu, mu plus mu is 2 mu plus mu. This 2 cancel, that is equal to mu plus mu, that is equal to 2 mu. As per definition, T2 is a biased, unbiased estimator, meaning you want to show that E of T2 equal to mu only, but is given and also find and end of result is E of T2 equal to 2 mu. Therefore, T2 is not a unbiased estimator, that meaning is a biased estimator. Unbiased is not a unbiased but biased estimator. Okay, biased estimator. This is a second part proof. Okay, what is a proof of this one? Our question is find lambda values completed. T1 and T2 are biased or unbiased. T1 is a unbiased and T2 is called a biased statement. Next, very important, shade the given the estimator is best estimator among the T1, T2, T3. Okay, that meaning best estimator meaning you want to find that separately variance. Okay, separately variance of T1, variance of T2 and variance of T3. Separately you want to find that, and what is the result is getting, and also which one is satisfied less than 1, which one is satisfied less than 1 condition, then that estimator is called a best estimator. Okay, therefore you want to separately find that variance of T1, T2, T3. Before that, I given the small formula. Okay, small formula. Suppose variance of Ax, meaning Constant term you will taking outside, meaning a squared variance of x. Okay, variance of x. This is a basic formula. Okay, constant term is there, meaning you want to taking outside, then that value is equal to a squared variance of x. This is a very important formula. You want to taking that part also. Okay, this is a very important part. Now I move to the next one, T1 estimator. Okay, this is a third part proof. This is the third part proof. T1 estimator. What is a T1 estimator value? X1 plus X2 plus X3 plus X4 plus X5 divided by 5. Now want taking variance both side. Now want taking variance both side. Okay. Then what is the variance value? Variance of T1 equal to variance of T1 equal to we're taking overall variance of x1 plus x2 plus x3 plus x4 plus x5 divided by 5. Now apply this formula. Now want to apply this formula. This is a single dimensional. Suppose multi-dimensional, meaning variance of a x plus a y, meaning want taking a squared variance of x plus a squared variance of y plus that means a into covariance of x comma y. This x and y are independent, therefore this is 0 only, therefore apply this two formula only. This formula only, therefore we want separately taking what is the variance of constant term? Variance of constant term is a squared. What is the constant term here? 1 by pi. What is the constant term here? 1 by pi. Therefore, I am waiting taking outside 1 by pi squared. 1 by pi the squared. Now we are writing the separately. That meaning variance of x1 plus variance of x2 plus variance of x3 up to variance of x5. Okay, variance of x4 plus variance of x5. Here normal distribution already you know, expected values is mu, and variance of x equal to sigma square. This is a formula. Okay, because given that normal distribution, already I given the formula normal distribution, the expected values is equal to mu and the variance of x equal to sigma square. That meaning variance of x1, variance of x2 up to total pi type is there, therefore variance of up to x pi equal to sigma square. So all values apply here. Variance of x1 value sigma 1 square, sigma square. Okay, this value is sigma square, and this value is also sigma square. This value is also sigma square. All values are sigma square only. Okay. Now add all things and is getting the result variance of T1 equal to 1 by pi squared. How many times add? 1, 2, 3, 4, 5. 5 times is add in the sigma square, therefore pi sigma square. So 1 pi is cancelled, is getting the result sigma squared divided by 5. This is a variance of T1. This is a variance of T1. This is a 1 by pi. 1 pi is a less than 1 condition. So 1 by pi is a less than 1 condition. Therefore, this is also T1 is also best estimator. Okay, T1 is a best estimator. Similarly, we can find the next estimator. Next part T2. So what is the T2 value? T2 equal to x1 plus x2 divided by 2 plus x3. This is a given that value. Now want taking variance both side. Now want to taking variance on both side. Therefore, variance of T2 equal to is getting the result variance of x1 plus x2 divided by 2 plus x3. Now we want to separately we taking variance, that is equal to 1 by 2 is a constant term, therefore I am putting that 1 by 2 square into variance of x1 plus variance of x2. So outside another one variance of x3, variance of x3, that is equal to 1 by 2 square, variance of x1 is sigma square, variance of x2 is also sigma square, plus variance of x3 is also sigma square. Therefore our values is 1 by 2 square, here 2 sigma square plus sigma square, 1 2 is cancelled, 1 2 is cancelled, therefore that is equal to 1 by 2 into sigma squared plus sigma squared. So taking LCM is getting the result sigma squared plus 2 sigma squared divided by 2, that is equal to 3 by 2 sigma squared. See now 3 by 2 is a 1.5 value, okay, 3 by 2 is a 1.5 value, is not less than 1, therefore T2 is not a best estimator, okay, is not less than 1, therefore T2 is not a best estimator. Now I am taking the last concept T3. T3 last one. You know the T3 is a given that what is the value? T3 equal to 2x1 plus x2 divided by 3. Now we want to taking variance of T3. Variance of T3 equal to variance of 2x1 plus x2 divided by 3. Now we want to taking separately variance, separate variance, that is equal to 1 by 3 here 2 by 2, therefore 2 by 3 whole square, 2 by 3 the whole square in the first variance, and the second variance only 1 by 3 is there, therefore 1 by 3 square, 1 by 3 square variance of x2, variance of x2. So now we know that this is called a sigma square and this is also called a sigma square, that is equal to, so what is the end of result? 2 squared is 4, therefore 4 by 9 sigma squared plus 1 by 3 is squared is 9, 1 by 9 is sigma squared. So total how much? Total denominator are same, therefore I am writing here pi by 9, pi by 9 sigma squared, pi by 9 sigma squared. So now consider pi by 9, pi by 9 means is also less than 1, pi by 9 is also less than 1, therefore T3 is also best estimator, okay. T3 is also best estimator. Now T2 is not a best estimator, and T1, T3. So T1 values, what is a T1 estimator, that variance values maybe, yeah, 1 by pi. 1 by pi means how much? 1 by pi, 1 by pi means 0.2, okay. And the next one is pi by 9. Pi by 9 means, so how much? Pi by 9 means 5 is a 0, 0, 9, maybe pi times 9 into pi 45, okay, nearby 0.5. Which one is very very smallest value, that one is very very good best estimator, okay. Two are best estimator, but compare T1 and T2 is a T1 is called a least value, therefore this T1 is called a good or best estimator, okay. This is a basic idea. This is 0.2 only, this is 0.5, both are less than 1, both are best estimator, then compare to T1 and T2, T3, so T1 is a good estimator or best estimator. T good or best are both are same meaning, therefore T1 is called a minimum value, therefore T1 is called a best estimator. This is a very, very, very important repeated problem. Any doubt regarding this proof?